Today we're going to be talking about the 5 practices, and they're designed to help teachers use students' responses to advance the class as a whole. So the five sequences or practices are one, which is anticipating, likely student responses, and it requires teachers to do the problem as many ways as they can. So then, when the class starts telling their answers, the teacher has different ways to help the students think and different ways to explain the problem to the students. The second one is monitoring, and it's monitoring students' actual responses to the tasks, and it's done in small groups. And one way to help monitor, besides walking around the classroom, is to create a list of solutions that the teacher anticipates the students will produce. And the teacher should always ask questions to get the students thinking. So the teacher should walk around, ask students, what are you thinking? Why do you think this way? Why don't you think this other way? Kind of like we do in this class. So it really makes you start thinking, maybe I'm not onto this, or maybe there's a better way to do this problem. Then there's selecting. The teacher selects certain students to answer the problem when it's time to get together. And the teacher should probably, I would think, select students who don't seem to be understanding, because it's very easy for, a student, especially in younger grades, to sit there and not say anything and, get lost because maybe they're embarrassed to admit that they don't understand what's happening. So this way, everybody in the class will be on the same page, and that's very important. And then there's sequencing, and that's making purposeful choices about the order student work is shared. And that maximizes the chances of achieving the mathematical goals because everybody's response is there in the right order, so it really gets every student thinking. And then there's connecting, and the goal is to have students presentations build on one another to develop the final mathematical idea, the whole point of the lesson. And that's very important because many students will who didn't even think of a certain idea will finally understand, oh wow, because of this certain way we can have a shortcut. Like even today in class, when we were talking about the Fahrenheit and sine, and it was amazing, and this was something that I didn't even think about, and it's very important for students to put all their ideas together, and then they can get a real grasp, and you get a real grasp on whether the students really understand what's happening. I think it's very important as a teacher, future teacher, to implement all these ideas because so many times during class students get lazy and they don't want to participate, and I think all these 5 practices really ensures that the students understand what's happening. They're able to think logically. They're able to understand the real mathematical idea, and not in a way that, oh, I'll just remember this for now and then after the test I'll forget about it and I'll never need it again. I think this really, really will help the idea stick in the kids' minds. And it also teaches them discipline. And I think it keeps them on their toes when they know that the teacher is always monitoring them, and the teacher can select them anytime and even use their responses in the sequencing part. So I think it's very important. And unfortunately, besides this class, I've never had anything besides monitoring, but not actually asking the students what they think. It's more, are you on point? Are you doing what you have to do? So I think it's very important.